chapter 8 and 9. 8 9, this is a very interesting. Direct variation is a concept that is covered in a lot of Algebra 1. It's not necessarily on a lot of placement tests, but you will see direct variation on it. So it again works within a, oh, that's nice, I remembered it. Works on a y equals mx, and m, or the slope, is my k for constant. It's my constant. Remember, slope is a constant rate of change, so k is our constant of proportionality. So we are going to use direct variation to solve problems. We have this relationship between an x and a y value, and then it will be proportional across all of its solutions. So given m varies directly as n, so m varies directly as n, m varies directly as n. So n is going to be the dependent on n. So that's why we know n is the independent variable, or the x, m is the y value. So it gives a relationship between the two values, and then we have to find the constant of variation, and then we find the k, and then we can write a formula for that. So we can write a formula that works for every situation. So this would be m equals 3n would be the equation that we could apply to everything. How did we get that? That's the k value, and we plugged it in because we knew the m and n and solved for k. So A is find the constant of variation. So we found the k, and then find the new value. So we would use this equation when n is 15, so we plug that in and we get m of 45. So we're just plugging in. We don't see that equation, but that would be important for us to understand how we can utilize that for the B problem. Okay, so y varies directly as x, so y is the dependent, k, and then our x value is independent. So step one is find the constant. So we find it by plugging in the values. We're given y and x, so 18 equals k times 3. We're going to divide by 3, 6 equals our constant. So now we can go over to here and we can have the formula. We know what the variation looks like. Y equals 6x, and now it wants to find the constant. Oh, well, it has no other value. So, but if we wanted to find another value, whether it be y or x, we can plug it into that equation. So they just want the constant here in the beginning. So y varies directly as x. Y equals kx. We get a y of 52. We're solving for my k, and my x equals 13. We're going to divide by 13, and we get 4 equals k. And I'll just write the new equation. That's good, helpful. That's a good habit to write that. So t varies directly as s, so t, k, s. We have negative 36 equals k times negative 4. Divide by negative 4. Divide by negative 4. 9 equals k. So my new formula would be t equals 9s. H varies directly to m. H is 368. K. M is 23. Divide by 23. 23, what could that possibly be? That is 1. That's 12, 13, 138. 138, 6? No. Oh yeah, maybe. Let's look. 368 divided by 23. Yeah, that's not bad, Mr. McCausland. So that's my constant. So my new equation is h equals 16, not k. m, because those are my two variables. H varies directly as m. Y varies directly to x, where y is 252. My k value, my constant, times my x value, divide by 18. 14 maybe. 252 divided by 18, 14. Yes. That's my k. So my new equation is y equals 14x. I can find any additional values after that. So t varies directly as s. T is 490 equals k times 14. Divide by 14. 14. I'm not even going to try that. Well, it's 5. No. 25? 4. No, it can't be 25. Divided by 14. 35. 35 equals k. That's my constant. So my formula would be t equals 35s. And these are nice. We don't really see the value of it just yet. We'll see it more with, these are word problems that we often see, direct variation. You see it in science. So y varies directly to x. So here we go. Now we have a problem where we have to find the constant. Divide by 5, divide by 5. We get 60 equals k. So my equation is y equals 60x. And now tell me what the y value is when x equals 15. So y equals 6 times 15. So y equals 0, 30, 0, 30, 900. 60 times 15. 60 times 15, 900. So my y value would be 900 when x equals 15. Y varies directly as x. Y is 10, k, x, 2, 5 is my constant. So y equals 5x. Find y when x equals 9. Y is 45. Nice and easy, right? I mean, how easy is this? H varies directly as A. So H is 4. Notice they switched how they gave it to you, so just be careful of that. Divide by 20, 1/5 equals K. Yes, your constants can be variables. So H equals 1/5 A. And find it when H equals 3. So they again tried to trick you. We're going to multiply by the reciprocal, which is 5. 15 equals A. So find A. Be careful of that. H varies directly as A. They give you A, which is 24. H is 8. K, 24. Divide by 24. 1/3 equals K. So H equals 1/3 A. Find A when H equals 4. Plug in 4 for H. Let's multiply by 3. 12 equals A. Y varies directly as X. My Y is 240. My X is 25. That's going to be a fraction, because no quarters are going to make 240 or $2.40. So that is going to be, well, let's turn it into a decimal just to keep it easy. 9.6. And yes, you can have constants that are decimals. Your equation just becomes this, 9.6x, which isn't a problem. So find y when x equals 40. 9.6 times 40 is going to be 24, that's 30. 4 times that, yeah, right? 9.6 times 40, 384. That's my answer. Last one, H varies directly as A. A is 6, H is 15, K, 6 divided by 6. 3 goes in that 5 halves. K is my constant. H equals 5 halves. A, find A when H equals 5. We're going to multiply by the reciprocal. 2/5. The 5 in the denominator is going to cancel with the 5 in the numerator. We get A equals 2. Let's see what the next problem. So here's our word problem. So the amount of interest earned on a savings is directly proportional to the amount of money saved. If $26 of interest is earned on $325, how much interest will be earned on $900 in the same period of time? So we have a direct variation. Okay, interest over deposit should equal interest over deposit. So we're going to make that check. Solution 2. To solve example by method shown in example 1, first write the equation I equals KD. Interest is directly proportional or varies directly to the amount of money saved. So D is the money saved, dollars. So I varies directly to D. And then we can use those two that we know, 26 and 325. 26 is the I, 325 is the D, dollars. And we can find the constant, and then we can plug it into there. So we'll do both techniques. We'll use both of them. I'm not adverse to that. We can show both techniques. So an employee's wages are directly proportional to the time work. So W equals K times T. So in the first one, we have wages. This is W, and this is T. So we have 120 equals K times 8. Let's divide by 8. Divide by 8. And we get 8 goes into 12, 1, 15. 40, yeah. So my constant is 15, so we can say W equals 15T. And now, what if we have 20 hours? So W equals 15 times 20. W equals 300, so $300. Now I would answer the question, how much will the employee earn? So that's why I have to write my answer with money. So that was one way. The other way we could have done is wages over hours. So wages, 120 over 8 hours is proportional to how many wages over 20 hours. So the way we could do that is cross product. So we're going to multiply. We're going to multiply those two, should equal the product of these two. Nice and basic stuff we've been learning. 120 times 20 equals 8W. That is 240,000 equals 8W. Divide by 8. Divide by 8. And we get 8 goes into 24 3 times, so that's 300 equals the wages and money. So either technique is okay. I kind of like this because we're dealing with direct proportionality, but I guess this is direct proportional also. 6 of one, half dozen the other. I don't mind which way we do it, as long as you show your work and that you get it right. So a certain car used 21 gallons of gasoline in 7 hours. If the rate of gasoline used is constant, how much gasoline will the car use on a 6-hour trip? The rate of gasoline, used 21 gallons in 7 hours. So I'm going to say gas equals K times time, because that kind of makes sense anyway, right? You're going to use a car, multiply that times 2, that's going to use your gas. This is independent, this is dependent on how many hours. So I'm going to go and say that. So 21 equals K times 7, divide by 7, divide by 7, 3 equals my K. And so my equation is G equals 3T. And how much gasoline will a car use in 6-hour trip? So G equals 3 times 6. G equals 18. It will use 18 gallons of gas on a 6-hour trip. Let's try the proportional. So gas over time, doesn't matter which one is numerator, which one is denominator. So 21 gallons in 7 is proportional to X over 6 hours. So we'll do cross product again. So this times this should work out. So we have 7 times X. We have 7 times X equals 21 times 6. 7X equals 126. Let's divide by 7. Divide by 7. X equals 18. So 18 gallons again. And it works out because that is in the numerator, which represented gallons. It's a good trick. I like it. The distance traveled by bus at a constant speed varies with the length of time it travels. So the distance equals the constant with the length of time it travels. So again, T. So distance, if a bus travels 192 miles in 4 hours, we divide by 4, divide by 4. That's going to be 448 equals K, so that's my constant. So we can write a formula, D equals 48T. How far will it travel after 9 hours? So D equals 48 times 9, 72. 7, that's 36. 43, 432 miles. What am I multiplying? 48 times 9. 48 times 9. 432. 432 miles. Not mules, miles. Good. And the number of words typed. So words equals directly proportional to the time spent, T. If typists can type 325 words in 5 minutes, divide by 5, divide by 5, we got 85 equals K. We get W equals 85T. How long will it take the typist to type 1040? So this time that goes in for W. 85T, divide by 85, divide by 85. So we're not going to even play around. 1040 divided by 85. Gah. All right, I see. So that's going to be 12 minutes. Hold on. 12. And what's 85 times 12? Gives me 1020. So 20 85ths, which equals T. I was hoping, well, let's do 12. So 5 goes into that 4. 5 goes into 85. 5 goes into that 17. So How long will the typist type? So 12 and 4/17 minutes. That's how long it'll take. Oh, all right. I think you should feel really confident with direct variation. Direct variation is relatively simple as long as you remember the template. And that template is y equals kx. So that's the real important thing, is understanding how to find the constant. So good luck.